factor a perfect square trinomial and a difference of squares. So these are two types of factoring where we have a couple tricks and patterns in order to recognize that it's a perfect square trinomial or a difference of squares, and then it's easy to factor. Okay, so a perfect square trinomial is in one of these two forms here. Okay, so the first term here is always something squared, and then the last term is also something squared. And then you have plus 2ab or minus 2ab. So this is how we recognize it. There's always three terms. The first and the last are perfect squares. That means you can take them and you can root it. So for example, 25 is a perfect square because it nicely roots to 5. Okay, 4x squared is a perfect square because it nicely roots to 2x. And number 3, the coefficient of the middle term is the root of the first term times the root of the last term times 2. And that's why we have 2ab. Okay, so let's take a look at the following 3 examples, and we'll figure out whether or not these trinomials are perfect square trinomials or not. Okay, so here we go. Are there 3 terms? Yes. Okay, number 2, can we root x squared? Yes, it would be x. Can we root 15? No. Okay, so we would say cannot root 15. And I mean, we can root 15, but it's not going to be a nice number. So it's not a perfect square. Not PS, perfect square. Okay, B. Can we root 16x squared? Yes, it'd be 4x. Can we root 25? Yes, it'd be 5. And sorry, number 1, there are 3 terms. Okay, so let's check this. The root of the first term, so we're going to kind of sub it into this and check if this is correct. Okay, the root of the first term would be 4x. The root of the last term would be 5, and then times 2. This would be 20, 40, 40x. Well, that's not times 2, that's just 20x. So not a perfect square. Now, the last one. Yes, there are 3 terms. Yes, you can root 4x squared. Yes, you can root 9. So the root of 4x squared is 2x. The root of 9 is 3. And then let's multiply that by 2, and we get 3 and 3 is 6, 6 and 6 is 12x. That is in the middle, so this is yes, it's a perfect square. So now factoring a perfect square trinomial. Okay, so fully factor the following. So what we want to do is we're going to have the root of the first term, then we're going to have the sign in the middle term of the middle term, then we're going to have the root of the last term. Okay, so this is the pattern. So what's root of x squared? Well, it's just x. Okay, and then the last term, which is 9. So what's root 9? Well, it's just 3. Okay, because this middle term has a positive, this is going to factor to x plus 3, x plus 3. In other words, x plus 3 squared. Okay, and if you actually check this against product sum, you could say, like, for example, just as a check, what are the factors of 9? Well, it's 1, 9, 3, and 3. Which ones add to 6, right? 3 and 3, that's where we get that double from. So you can factor it by product sum, you can factor it by decomp, like normal, but if you recognize that it's a perfect square trinomial, you can use this shortcut. Okay, next one. Let's factor the front number. So 25w squared would be 5w. Root 4 would be 2. And then the sign in the middle is positive. So this is 5w plus 2 squared. And just that check, that third thing on the check, if we had 5w times 2, so the root of the first times the root of the last times 2, we would get that 20w, which is that middle term. Okay, so you can go ahead and check this, but you can also do that as decomposition. Okay, next one. So a little bit looks a little bit the same, but this time this middle term is a negative. So we're going to do the same thing. We can root the first term, which is 5x, and we can root the last term. So this would be 5x plus minus 2. So minus 2, because this is a negative. Okay, so this one's a little bit different, a little bit more complex. Okay, so what we're going to do is we're going to focus actually on this part of the equation, okay, without the d. So, can you root the first term? Yeah, you get an x. Can you root the last term? Yes, you get a 4. Now, is that middle term the root of the first term times the root of the last term times 2? 8x? Yep, that's correct. So we can go ahead and use perfect square trinomials just for this trinomial in here. So what we would get is the root of the first term plus the root of the last term squared. Okay, but remember, you're not done because you have to bring this negative y squared down. So now we're going to recognize this as what is called, and we're going to get into a little bit more, difference of squares. Okay, so how we can recognize difference of squares is, first of all, it's a difference. So it's a minus sign, and we can root the front, root the first term, root the second term. So when we root the first term, we get x plus 4. And when we root the second term, we get y. So the pattern here, and we're going to get more into the theory, is the first term, x plus 4, plus like the root of the second term, and then the root of the first term minus the root of the second term. Okay. Now, let's take a look at this one. This is a perfect square trinomial. So this will be the root of x squared, which is x, the root of 25, which is 5. So we have x plus 5 squared. Now what I'm going to do is I'm actually just going to factor out this negative, so the negative 1. So I get y squared plus 6y plus 9. Okay, can we root the first? Yes. Can we root the last? Yes. And is that middle term 6y? Yes. So we can go ahead and use perfect square trinomial with this one as well. The root of y squared is y. The root of 9 is 3, and this is a positive here. Now I'm going to show you that difference of squares one more time before we go into it. So difference of squares, we have two terms. You can root the first term. Root of x plus 5 squared is actually just x plus 5. And the root of y plus 3 squared is just y plus 3. And there's a difference in the middle. So difference meaning subtraction. So the root of the first term minus the root of the second term. And then the root of the first term plus the root of the second term. Okay, if we were to simplify this, we would just expand this. We get x plus 5 minus y minus 3. And then we'd get x plus 5 plus y plus 3. And that would leave us with x minus y plus 2. And then that would leave us here with x plus y plus 8. Okay, and always remove the common factor before factoring by perfect square trinomials. Okay, you always want to remove the common factor first in anything that you're doing with factoring. So what can I pull out of 36, 48, and 16? I think I can pull out an 8. Sorry, a 4. Okay, so because I'm pulling out a 4, I'm left with 9y squared minus 12y plus 4. Okay, so let's do the check. I can root the, there are 3 terms, so check 1. Okay, check 2, I can root the front and the back. And check 3, the root of the front is 3y, the root of the back is 2, and times 2 would be 6. 3 and 3 is 6, 12y. Yep. So this is a perfect square trinomial. So we're going to do the shortcut method. What's the root of the first? 3y. We're going to use this sign, which is negative, and then the root of the last, which is 2. So we have 4 bracket 3y minus 2 bracket squared. Okay, what about this one? We can take out a 3, and when we factor out a 3, we're left with w cubed plus 8w squared plus, oh, we can also take out a w. So let's take out 3w. Okay, so we're left with w squared plus 8w plus 48 divided by 3, 16. Okay, 3 terms, we can root the front, root the back, and then 4 times w times 2 is definitely 8w. So we can go ahead and use perfect square trinomial. We get w plus 4 squared. Now we're going to take a look at difference of squares, which is already introduced. But difference of squared is in this form. Oh, this would be a squared minus b squared. So this is how to recognize. There are 2 terms. Both terms are perfect squares. That means we can root them. And the sign in between the 2 terms is subtraction. It has to be subtraction. Okay, it's a difference of squares, not the sum of squares. So we're going to take a look at these binomials. Okay, so binomial, we're already saying that there are 2 terms, right? So one is already satisfied. Okay, are they difference of squares? So yes, there are 2 terms. You can root x squared, you can root 81. Okay, is the sign between them subtraction, not subtraction. So not difference of squares. Okay, there are 2 terms. Can we root them? Root 7 doesn't root nicely, so not difference of squares. Okay, 2 terms. We can root them. Oh, yeah, we can root them both. And then the sign is subtraction. So yes, this is difference of squares. Okay, we can't root. Sorry, there are 2 terms, but we cannot root y cubed nicely. So this is not difference of squares. Okay, so now let's go ahead and factor a difference of squares. So the setup for it, and we took a look at this before, but it's the root of the first term minus the root of the second term, and that's all in one bracket. Then the root of the first term plus the root of the second term. Okay, so what's root of n squared, or x squared, was just x. Okay, so that's going to be that first term in both brackets. Okay, now we're going to have one subtraction, one addition sign. And what's root 64? 8. Done. Okay, so this one, what do we get when we root 4y squared? Well, we get 2y. One's going to be addition, one's going to be subtraction. Root 81 is 9. Okay, so they get a little bit more difficult. So can we root these? Yes, I'm going to show you how to root that in a second. So root of 16x squared is 4x. So that's going to be that leading number in both brackets. Then one is going to be addition, one subtraction. It doesn't matter which one. Now, how do you root 9y squared? Well, we know the root of 9 is 3. And if we think about what, like y to the what times y to the what is going to equal y to the 6, well, we know that with exponent laws, we're going to actually add these. So what plus what will equal 6? Well, it's going to be 3. So this is y cubed. And that's it. Okay, same logic here. We're going to have 3x as the front number. We're going to have one addition, one subtraction. And then when we root 25, it's 5. When we root y to the exponent 4, we get y squared. Because if we were to reverse this and expand it, we would actually get 5y squared times 5y squared, which would give us that 25 y squared times y squared is y to the 4. And that's how we get back to the original. Okay, so we saw this in the first one. Can we root x minus 2 squared? Yeah, well, it's x minus 2. So that's going to be the leading expression in both brackets. One's going to be plus, one's going to be minus. Now the 16, plus 4, minus 4. So in a situation like this, we're going to actually have to go ahead and simplify this. So what's negative 2 plus 4? Positive 2. And what's negative 2 minus 4? Negative 6. Okay. Last one for this set. The root of y minus 4 squared is just y minus 4. Plus, and then minus. Now the root of w plus 3 squared is going to be w plus 3. Here's the thing, since this is an expression, we're actually going to put this in brackets here, and we're going to expand this negative sign into that bracket. So we can go ahead with the first one and simplify already. So we're going to go y plus w, but now we have negative 4 plus 3, so minus 1. And in this bracket, we're just going to go ahead and distribute that negative sign into the bracket. So we're going to get negative w and negative 3. Now let's collect these two. So we're left with y plus w minus 1, y minus w minus 7. Okay, so same theme, always common factor before factoring by difference in squares. So example 6 and 6 is going to be fully factor the following. So what can we pull out of both 100 and negative 4? Well, we can pull out of 4. Okay, so we're left with 25. Oh, the first factor would be 4. Then we'd have 25 minus y squared. So it's okay that these two are a little backwards. Usually we're dealing with the variable in the front and then the constant in the back, but that's okay. What we'll actually do is we'll pull out that negative sign. Yeah, let's pull that out first, okay? So if we pulled out a negative, so negative 1, what we're going to get is we're going to get negative 25 plus y squared. But let's just rewrite this and flip it. We get negative 4 y squared minus 25. Okay, so proper math form, we always want to write the, in the bracket, we want to write the variables first. So now, what's the root of y squared? Well, it's y. What's the root of 25? It's 5. So plus 5 minus 5. And that's it. Okay, B. What can we pull out of 8x cubed and then negative 32x? We can pull out definitely an x. And we can pull out 24. We can pull out the full 8. Okay, so 8x, and then we're left with x squared minus 4. Okay, so we can root x squared, we get x, and we can root 4, we get 2, so plus 2 minus 2. Okay, number 7, determine two values for k so that each of the following binomials can be factored. Okay, so because there are two terms here, and there's a negative between them, we're going to do difference of squares. So k can be anything that we can root. So it could be 64, it could be 25, it could be 9, okay? Any number that we can root. Okay, what about this one? So we can root 4x squared. Now there's a negative sign between them and there's two terms. So this is definitely going to be difference of squares as well. So this one's already taken care of. Now we have 6ky squared. So here's the thing. We can already factor y, or sorry, root y squared. So we just have to be able to root 6k. So 6 times what number would give us something that can be rooted? Well, if I went to the side of my paper and I wrote out just nice perfect squares, 1, 4, 9, 16, 25, 36, 36. Okay, so if we did k equals 6, we would get 36 for that number, and then it can be rooted. Okay, so let's keep going. So that's 6 squared. We can go 49, 64. 64 does not divide by 6. 81. Nope. And I'm just dividing these just on my calculator. 100 doesn't divide by 6. Okay, 121 doesn't divide by 6. What about 144? That definitely divides by 6. So 144 would be 6 times 24. So if we multiplied this 6 by 24, we would get the 144, which would make which would allow us to be able to root it. So 6 and 24 are two possible answers. Okay, and the last one. We have x squared, which can be rooted, and we have 25, which can be rooted, but there are three terms, so we're going to assume that this is going to be perfect square trinomial. Okay, perfect square. So this middle term always has to be 2 times the root of the first, which is x, times the root of the third, which is 5. So this middle term has to be 10x. That means k has to equal 10. Okay, so k can equal 10. K can actually also equal negative 10, which would flip this sign in here. If k equals negative 10, it would flip the sign to a positive, which still works. All right, factoring applications. So a store in the shape of a square with side lengths x minus 2. So this is going to be also x minus 2, of course, because it's a square. Okay. Is built on a square lot. So again, another square with side length x. So that's x, and this is x as well. Okay. Find a simplified expression for the area of the visible lot around the store. Okay. And then factor the expression to find the dimensions of the visible lot. So the area of the gray, okay, so the area of the lot is actually going to be the area of the large square minus the area of the small square. Okay, so the area of the lot is going to be x times x, so x squared, minus x minus 2 squared. So when we're looking at this, we can identify that this is difference of squares already. Okay, if it does want it completely simplified, what we can do is we can expand this one. So we're going to go x minus 2 times x minus 2. Okay, so we're going to go x squared minus, and you got to keep that minus sign there. And we're just going to expand 2 at a time. Okay, that's the rule. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 minus times x is negative 2x again. And then we have negative 2 times negative 2, which is positive 4. And I'm just going to go ahead and collect those inside terms. Okay. Now what we want to do is we want to distribute this negative sign into the bracket. So I get x squared minus 4x, plus 4x minus 4. these cancel, I'm left with 4x minus 4. So this here is a simplified expression. I expanded everything, I collected like terms, and I simplified it. Now let's go ahead and factor this, okay? So the area of the lot, all we're going to have to do is common factor, and all we can pull out is a 4, okay? See how we don't have a squared here? We don't have to pull out an x, and we don't have to do difference of squares. We're just going to pull out a 4, and we're left with x minus 1. Okay, so the dimensions are 4 by x minus 1. This means by, by. Example 2. An expression for the volume of a square-based prism is the volume equals x cubed plus 16x squared plus 64x. Find the expressions for the length, width, and height of a square-based prism. Okay, so what we're going to do is we need to find three terms or expressions that multiply by one another in order to expand to this. So what we're going to do is we're going to reverse that and factor it. So let's go ahead and divide out the x. Okay. So we get x squared plus 16x plus 64. So that's just common factoring. Now, we can recognize here that we can root the first term and root the last term, which is x and then 8. And then x times 8 times 2 equals this middle term. So this is actually a perfect square trinomial. So the root of the first term is x. We use this sign, and the root of the last term is 8, and then we square it. So therefore, the length is x, the width is x plus 8, and then the height is x plus 8 as well. Those are the three dimensions.